Hello geometry class, welcome to the video on section 8.3. Today we'll be primarily talking about similarity of polygons. So the essential question here is, how do I use the similarity of polygons to find the scale factor between shapes? And then we'll use that information in order to find the lengths of certain sides of shapes. So have your proportion skills ready and let's get started. So first off, similar polygons. Okay, they're simply defined as polygons that have exactly the same shape, but are not necessarily the same size. Okay, we will use this little squiggly line, tilde, if you will, to indicate similarity. And we know that the corresponding angles of polygons that are similar, let's put similar in here so it's proper, similar. The corresponding angles of similar polygons are congruent. So the best way to think of this is if we're taking a figure and exploding it, or making it bigger. So say we had a small triangle right here, okay? Pretend it's equilateral, so all the angles are 60, and we made it just larger, right? We extended all the sides, okay? So now we have, again, an equilateral triangle. Again, all the angles are 60, so these angles are congruent to one another, but the sides just got bigger. Okay, those figures are going to be similar. They have the exact same shape, but one is just larger. Okay, so we would say triangle A is similar to that of triangle B. Okay, so we can use a similar idea to calculate the sizes of certain shapes. Okay, now scale factor is something we've defined before. It is the ratio of the lengths of two corresponding sides of two similar polygons. I really hate this definition. The one that I taught you earlier when we learned about transformations and dilations is I taught you that the scale factor is equal to the image over the pre-image. Okay, that's the wording I taught you earlier in the year. If you don't remember what the image and the pre-image is, remember the image is the new shape, the one that we're going to, and the pre-image is the old shape, or where we started at, okay? And so if you want to think, well, it's the same thing as the new shape over the old shape, that's great. And I'll probably use this one right here during this video. I'll talk about new shape over the old shape, okay? So where we're going over where we started, that will be the scale factor, right? And so if you're looking at this right here, say we're going from the small triangle to the big triangle, and we're looking at our scale factor. Remember, that would be an enlargement, right? The triangle is getting larger, and so if we were going from small to big here, our scale factor would have to be a number that is bigger than 1, because it's getting much bigger, right? Because the new shape divided by the old shape would be a large number. Okay, that's how we're going to look at this today. So let's use this a little bit to do this. Number 1 here, we have quadrilaterals ABCD and EFGH are similar. Okay, again, we know what that means now. We need to list all the pairs of congruent angles and then write the ratios of the corresponding sides in a statement of proportionality. It's very fancy sounding. Okay, very easy though. So first off, for the angles, let's do this in blue. This would not be bad at all. Okay, just like in triangles, when we have congruent triangles, the way these are written kind of tells how it works, right? Look at the picture. This A is the same as E, so we can say that angle A is congruent to that of angle E. Remember, the corresponding angles are congruent. Angle B is going to be the same as angle F. Angle C is going to be the same as angle G. And the last one, angle D, is going to be the same as angle, what did I miss? ABCD, angle H. Okay? Those angles are all going to be the same. You can mark them if you wanted to. Now, the statement of proportionality. So this is when it gets kind of weird. But we know that AB, that's this side up here, right? That one over EF, those two are corresponding. That ratio is going to be equal to that of every other one. So we could do BC over the corresponding side of BC, which is FG. Okay? Those are equal. But that is also going to be the same as CD, the bottom, over HG, the bottom over here, which is equal to the left side here, AD over EH. Okay, we write that because this proportion, you could get rid of any of these. Right now we have 2. That proportion allows us to create an equation where we can solve for certain pieces. Okay, these things all set up very nicely and they're very wonderful to work with. Okay, so this side over that side is congruent to this side over that side. That's kind of going to be the setup of every problem that we do today. Okay. On to number 2. This is the big idea, right? Here's the questions that we're going to answer in our homework. We have pentagon ABCDE is similar to pentagon JKLMN. Okay? So we need to find the value of x and then find the scale factor of ABCDE to JKLMN. Okay, so there's 2 questions going on here. We need to find out what x is, and then we need to find the scale factor. So let's do the first part in blue. Okay, remember the pentagon ABCDE is similar to this one, so it tells us which sides are the same. So AB, for example, that's the first 2 pieces of the pentagon. That's going to be the same as JK. So this has kind of been a spun over pentagon. So AB, so let's go 5 here, over the corresponding part to AB. So AB is the same thing as JK. So JK is right here. So 5 over 6 is equal to that. BC is 4. Now BC is the same thing as KL. KL is X. We could keep going with all the other sides if we wanted to, but now we have a proportion that we can solve. Now we talked about how to solve this last week, and to solve this we simply cross multiply. So we would go 4 times 6, which is 24, is equal to 5x. X is equal to 24 over 5, which is a completely reasonable fraction. So this piece right here would be 24 over 5. That's a fine answer. Okay, now there's some things to look at here. We need to remember that we're looking for the scale factor of ABCDE to JKLMN. So that we need to know, well, to find scale factor, we need image over pre-image, or the new shape over the old shape. So some teachers teach us differently, but we need to talk about which one is the new shape and which one is the old shape. To me, the English there, it says we're starting at ABCDE and we're going to JKLMN. So we're going from here down to here. So this would be the new shape, and this would be the old shape. So pick whatever number you want. Let's pick 6. That would be 6 on top. That's the new shape. And the old shape, that corresponded to the 5. So this would be 6 over 5, and that would be our final scale factor. Now before you move on, ask yourself, does that make sense? We're going from a small shape to a big shape. Our scale factor is bigger than 1. Absolutely, that makes sense. Okay? So this is how these similar figures are going to interact, and that's how the scale factor is going to work. We're going to use this little equation right there, that image over the pre-image, and that will help us solve any questions that we have. On to number 3. Find the value of x in the similar triangles. What is the scale factor of the smaller to the larger? Okay? So now we only have markings to go off of. Remember, just pick the corresponding sides and go from there. So we can go, well, we have 40. That has to go over the 30. That is fine. Does not matter what order you set the proportion up. It's fine. So we have this one over that one. And now the x plus 15 goes with the 18. It's between the 1 and the 2, between the 1 and the 2. So we have the bigger side that we're going with here, x plus 15, over the smaller side, which we'll call 18. Okay, go ahead and solve that for me. Pause me so you can get the right answer. Okay, continuing. 40 times 18 here. We have 720 equals 30x plus whatever 15 times 30 is. I believe 450. Yep, 450. Subtract the 450. I'm not going to mess this up in front of you. 270 equals 30x. X should equal 9 here. Okay? Just to make sure, 9. So our x value is 9, and that's great, right? So this side right here, just for future reference, is going to be 24. Okay? And so now we need to find the scale factor from the smaller to the larger. So you need to ask yourself, are we going from this one to this one, or from that one to that one? It says from the smaller to the larger, so we're going from right to left. So this would become our new, and this would become our old. And if that is the case, the scale factor would be new over old, or 40 over 30. Okay, you could also use 24 over 18, you will get the same answer. Now 40 over 30 can be reduced to 4/3. And that is a fine answer. I'm happy with that one. Okay, I'm going to write equals SF and square it off. Okay. Alright, on the next page, almost done. Let's do a few more of these. Number 4 here. If triangle ABC is similar to that of triangle DEF, find the perimeter. We're looking for perimeter. Okay? And so what we need is we need all three sides of both triangles of this triangle to find the perimeter, but we can easily do that. Okay? So AB corresponds to that of DE, so we can go 5 over 3. Now to find EF, you would just go 6 over X. Put X right there because BC and EF correspond. That will let you solve for X. You could do the same thing to solve for Y, which we'll call DF. You could do 5 over 3 equals 7 over Y, and you simply have both sides solved. So let's do this rather quickly. Cross multiply, and you would get 5x equals 18, or x equals 18/5. So that's our x value. And for y, you would get 5y equals 21, or y equals 21/5. That's our y value. Okay? So those numbers aren't very nice, but it's fairly simple here. To get the perimeter of triangle DEF, we'll put P. You would take 3 plus 18 over 5 plus 21 over 5. 3 on its own, put over 5 would be 15 over 5. And so you'd have 15 plus 18 plus 21. Is that a nice number? It is not going to be a nice number. We have 54 over 5 as our final answer. Can't reduce that. It's what, 10 4/5? 10.8? That would be our perimeter of that shape. We'll put 54 over 5 units, just to be clear here. Okay? But setting it up and finding these other pieces of the triangle, rather simple. I'm just using the fact that those are similar triangles. Okay? Number 5. Given that ABCD and QSRP are similar, find X and Y. Now, if you're this far in the video and you understand what we're doing, you understand that the similar figures gives us congruent angles and they gives us sides that are in proportion, you're good to go. I'm just doing examples now. But if you want to see some more examples and see some work done, feel free to hang on. Okay? So remember, similar figures here create congruent angles. And so D here, that is congruent to P, which is over here. Okay, it doesn't look like that's how the shape is, but remember, these right here are very important statements. So D and P are the exact same, so we can set x plus 34 equal to 97. Very trivial to solve. Subtract 34. You get 63. Okay, so that one's already done. And for y, that's this r angle. R is the same as c, so that's 83. You would do 3y minus 13 equals 83. Again, quite easy to solve. Add 13 first. You get 96 and divide, and you get 32. Okay? Nothing crazy there. Nothing crazy at all. And the last one, number 6. Now, this is one of your quiz questions. Are the following triangles similar, yes or no? Now, if you just put yes, I would not give you full credit, right? If you put no, I would not give you full credit. You need to show me the reasons that those things are actually similar. Now, in the world where they were similar, I would be able to create a proportion based on that, right? So I would easily be able to say here, so notice here we have this angle 42 here and this 42 here. Okay, it kind of looks like it flipped over. So I would be able to say that 18 over 12, this angle over this side over this side, is indeed equal to 24 over 16. If that is true, then those triangles are similar. If it's not true, then they're simply not similar. Okay? So what you can do to check that is you can cross multiply. We have 18 times 16. Oh, typed that wrong. Okay, that's 288. Is that equal to 24 times 12? I believe it is. 288. It sure is. Okay? Now, since those are equal, then they are similar. Okay? If they were not equal, then these would not be in proportion, which would tell us those triangles are not similar. And that will end section 8.3. My co-teacher, Ms. Bador, will be making a homework video. Make sure you watch that. But otherwise, have a wonderful day.